Hey guys, this is your friend Maynard from Civil Center and I welcome all for back to our channel and another video on Staad.pro. So friends, in this video tutorial, we'll cover the entire steps of the design of a G+1 residential building in Staad.pro as per IS code. So if you have ever bumped into our channel for the first time, you can subscribe to our channel for videos related to Staad, Tekla Structural Designer, Tekla Structures, Revit Structures and almost all software and concepts related to civil engineering. So now, without wasting any time, let's get started. So first of all, we can see we have this particular beam column plan made in AutoCAD already, and now we need to find out the coordinates so that we can import those coordinates in Staad. So as you can see, this coordinate, if we do this x and y, so this coordinate 0, 0, we can simply copy this and write the next coordinate here. So the next coordinate will be, as you can see, 0, 4826, 0. So this is the x and this is the y. So we are just doing this. So the next coordinate can be your value of that next particular coordinate. We'll have one here. So at all the intersections, we need to have coordinates. So as you can see, this is 8738 center to center distance. So this will be 8738, this one, and comma 0. So this is the coordinate of the first line. The next one, let's just copy this and you can place it here. So the x coordinate will be 0 and the particular z coordinate will be your 4521. So this will be 4521, and next one will just copy this to here. Next one will be your, as you can see, the distance 1981. So it will be 1981, 4521. Next coordinate, we'll just insert it here, and this one will be, as you can see, the distance between this, as you can see, 4826. So here it will be 4826, and this 4826, and here it will be the next point. Here it will be, as you can see, 6.604. So here it will be 6.604, or if you are doing mm, you can just do this as 6604. So this is in which we are doing it. So after that, what we can do is make the next coordinate here, and for the next coordinate we'll just choose this one. So this will be 8738, this one, this will be 8738, and the top ones will decide now. For the next coordinate, we'll just copy this one, and from the bottom, as you can see, the distance 66, this one 6609. So we'll just change this to 6609, and this one, let's copy from here and then copy. We'll just change this to 6609, the y coordinate. So after that, let's define the next set of coordinates. Here we'll just copy this. So next coordinate will be 9017. So y will be here 9017, and copy this one to here. So this x will be 1981, as from here you can copy this 1981, and then we'll just copy the next one. So the next one, this one will be your 3912, and this one, that is the next one we already have here. This will be 6604. So this one will be 6604. Just note this. Okay. Next one will be your 8738. This one, let's do this as 8738, and we'll copy this the next level. So this x coordinate will remain same, the y coordinate will change, it will be 12090. So let's do this as 12090. So after that, next one also just quickly copy and paste it here. So this will be 39, instead of 3912 it will be 8738, 12090, and just copy this once again, and it will be here 113.538. So it will be 13, do this as 13538. and after doing this, just copy to here, and this will be 33912, and this one will copy this, and this will be your 8738. So we have defined the coordinates here. Now we can import this into the stat file. So let's go to the stat. Let's create a new folder. I have named that stat model for YouTube, and in this new folder we will be saving our stat file. So I'll just name this structure 1, and in this I will save my stat file. Please remember, for every separate file, make separate folder for your stat, because there are many particular files which come when they are saved. So I'll also do an Excel file here. I'll also go for an Excel worksheet, and in this Excel worksheet I will just insert the coordinates here, and we'll just, what we'll do is we'll write the coordinates here. So let's do this as x, y and z, and then 1, and then you can just use a command here, +1, enter. So like this we can just increase the nodes up to how much you want, and we'll just insert the coordinates here. So we can also insert the coordinates in stat directly, but we can also import them. That process will be helpful, because if you want to create multiple files, if you have this particular coordinate file, you can always import this. So before completing our coordinate file, let's open Staad.pro, and while we open the Staad.pro, we'll just open the Staad.pro. After opening Staad.pro, just click on this new project, and you can name this anything, and just keep the location of the folder in which you are we have created right now. We have just created a particular folder, stat model for YouTube and structure 1, and then click on OK, and then meter or units will be meter and kilonewton. This is the unit in which we are going to use, and then next, and then I'll just click on finish. So after that, the stat file will open, and when the stat file opens, you can then go and insert the coordinates. We can also use this snap node beams, but we don't need this right now. So we'll just insert the coordinates. Now as you can see, we have coordinates of x, y and z. So x and z are in the particular plane, and y is upwards. So we also have to adjust our coordinates according to that. So our particular coordinates, which we'll see if we just go and check from your plus y minus y view, or your plus y view, you can check here that this is x and this is z. So like this we can define our model here. So first of all, let's define our coordinates here, and then we'll just import them into our stat. So 0 0, and the next coordinate, as you can see here, this is 4286, 0, 4286, and y will be always 0, and this is 0. And next, as you can see, 8738 comma 0. So next we have 8738, and the next one we have as 0 comma 4521. So x is 0 and z is 4521. So if you want to, if the unit is meters, so let's just also take these units into meter. So this will be 4.521, and then, as you can see, and then the next one will be your 19814521. So it will be 1.981. This one will be the same, and the next one will be your 4. Okay, we have 3 more, so 4.826, 6.604. So just write here 4.826, 6.604, and then 8.738, 8.738, and then the next point which we'll have here is 0 comma 6.609, 6.609, 0, and then the next point will be 1.981, 1.981. This one will be copied. So as you can see, this will just go to the next coordinate, 0 comma 9.017, 0, 9.017, and we'll have the next point 1.981, 3.912, 1.981, 3.912, and then 6.604, 8.738, 6.604, 8.738. Let's copy this. Now for the next level, this one 3.912, 12.090, 12.090, 3.912. We have one more, that will be 8.738, and along this we'll have the last level 13.538, 13.538. First one is 0, next one is your 3.912, 3.912, and the next one is 8.738, 8.738, 20. So we have total 20 coordinates. Just y will be, as you can see, y is the vertical axis here, so it will be 0 here. So if you place this coordinates right here, and if you just go to Staad and then just enter those coordinates here, and after that we'll just check in the plus y view. As you can see, this is the plan which you are seeing here, and if you match it with this particular plan, as you can see, all the points which you want to visualize is shown here. This is a room, and this is the as you can see, this one, from if you actually see from the minus y, it will be properly visible here. So as you can see, one of the coordinates seems out of place, so like this you can check whether all the coordinates are in place or not. So if you go to the CAD file, you can check this is 4.826, 4.826, and you can always check this, what is the coordinate of this. You'll just need to select this coordinate cursor, and you can check this is 4.286. so this was a mistake here, so here you can just do this 4.826, and after that we'll just do this as 4.826, and after that this will be corrected. And you can also modify this in the Excel file as well, because in the future if you want to import this Excel file, then there shouldn't be any error. So this one is it is. So just do this as 4.826. so now we are good, we have done the correction. So now after doing that, we can just go for the option of add beams, and you can add the beams. Make sure you add the beams left to right, and then you will just go from bottom to top. So while adding the beams, make sure you have this particular this beam column plan, and we'll add the beams accordingly. We'll join the beams in the positions in which we have made this particular beam column plan. So the next point, as you can see, this be joined, and before that we will just join all the bottom to top here. So it's like this, as you can check. We will keep checking the beam column plan regularly, and then join this. And after that you can join this. After that join this. You can also check, join this one as well. This one is for the staircase, as you can see here. This is for the staircase. The cross marks denotes that is a staircase, there is no slab above it. So we'll join this. Always make sure you have the beam column plan with you while joining this, because we have to join according to the beam column plan available with us. So now we can go to this 3D view, and then we can select this entire particular structure, and then we'll go to the option of this translation repeat. So translation repeat we'll do in the Y direction, and then in the Y direction we'll just do this default step spacing as 3 meters, and click here and then click on OK. So make sure we have this Y direction chosen here. So with the help of your mouse cursors you can rotate this model, and with the help of up and down you can do this as well. So you are free to rotate this. So now we'll connect our columns. While connecting columns, please ensure that you have the beam column plan with you, because we'll assign the positions of our particular columns accordingly. So now if you view it from here, you can check this from here. If we just rotate this model so that we can suitably place the particular columns. So as you can check here, just select your suitable view in which you can add your columns. So here, as you can see in the CAD file, this is our first column. In this line we have 3 columns, 1, 2, 3. So we'll just insert, take add beams, and just insert the particular columns. And after that we'll insert the next set. So in here we have 1, 2, 3, 4 columns, 2 columns here, there is 1 gap, and then after that all 3. So this one will select, and this one will skip, and this one will select. This one is for the staircase, and this one is the end of the staircase. So in the next part we don't have any columns here. In the next part we have 1, this one is skipped, and 3, total 4. So we don't have any columns here. We'll just do this, and if you want you can rotate the model to check which is your point. This is skipped, and this one will connect to this one. This one is for the staircase, and the next at the ends we have for all the 3. So we have chosen all the columns correctly. Now you can check what are the number of columns: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There are 14 number of columns here. So you can also check here how many columns are here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 number of columns. So we are okay to go. We are good to go. So now what we can do is we can simply go to the front view and we can select this particular thing and we can go to the translation, repeat y direction, again 3 meters. This time we have selected the beams and our columns. Then just click on OK and then go back to the 3D view. So as you can see, we have made the model successfully. So after that, go to your general and then define some supports. So we're defining fixed supports, which denotes that the particular, this is the plinth level and the position of the columns and the foundation below are monolithic in construction. So we'll select this support and we'll assign this support to all below all columns. So use cursor to assign, and also you can just select, go to this support once again, select this and then select one particular column, and then with the help of control button select all the columns which you select the base of all the columns which you are seeing. So like this you can count also for there are 14 number 1 2 3 4 5 6 7 8 9 10 11 12 13. So you can check one column is missing here, just to rotate it to have a better view, and then this is the 14th column. So we have 14 column, and now assign to selected nodes. Yes. Now we can define the properties. In the general you have the option of your properties here. So we'll go to define and then define the properties of the particular beams and columns. You can define separate properties. Go to rectangle and we'll define 250 to 300 size. Initially we will take, but we will give a separate load that is properties for our columns and beams. So 300 we have to write downwards, and 250, as you can see, 250 you have to write downwards and 300 upwards, and then click on add. And after we add this, and then we'll just delete something, and then again we'll add the same property. So we have taken the same size, that is 250 to 300, and we'll assign it separately to our beams and columns. We've prepared two separate cases so that if any failure occurs later we can change. So we selected once, and then we'll go to the front view, and then with the help of the control button we'll select all the beams here, and then we can assign it to the selected beams. So once the beam are assigned, then it's time for the columns. So the next load combination will property will select, and then select beams parallel to Y, and then I will assign this yes. So as you can see, we have assigned our particular properties for our columns and beams. So the modeling is now complete. For further steps, stay tuned to our channel. Bye bye.